The White House launched Gold Eagle this week as a clearinghouse for cybersecurity vulnerability coordination. Its own announcement says federal agencies, AI companies, and critical infrastructure operators would share access to advanced systems so they can find and patch serious software flaws faster. Then CNBC reported something more consequential. The administration has also been deciding which companies get access to some new frontier models. So imagine you run a security company with a plausible case for early access. Who hears that case? What evidence do you bring? And what happens when the lab and the government give different answers?
The clearinghouse suddenly has two jobs that sound adjacent until you try to write the rules. Coordinating a vulnerability disclosure means deciding who needs technical details about a flaw. Allocating a frontier model means deciding who gets a capability before other people do. The second decision creates commercial winners, research winners, and possibly security winners. I can understand why the government wants a hand on that decision when the model can find vulnerabilities. I also want to know whether a small defensive security lab can appeal a denial without already knowing the officials or the frontier lab.
CNBC's report places OpenAI and Anthropic inside that access discussion, and the White House release presents Gold Eagle as voluntary coordination around cyber defense. Those descriptions don't yet amount to one settled program. Pause. The public announcement gives us a mission, while the reporting gives us a power. Federal influence over early model access. A mission can stay broad. A power needs criteria. Does the government rank applicants by national security value, their ability to secure the model, their prior vulnerability work, or the economic benefit they promise? The criterion determines the queue.
And every queue leaks a worldview. If prior government contracting experience counts heavily, established defense firms move forward. If published security research counts, universities and independent labs have a chance. If the model provider supplies the risk assessment, the lab still has enormous influence over a federal decision. My concern is procedural rather than theatrical. An applicant needs to know why it lost, and the person hearing an appeal can't simply repeat the first evaluator's judgment. Otherwise, access becomes a relationship business wearing a security badge.
There is a legitimate problem underneath this. The newest models can have capabilities that labs don't want to distribute casually, while selected outsiders may be exactly the people who can discover where the model breaks or where it can help defenders. Labs already run private previews and trusted tester programs. Gold Eagle could add a public institution to a process that has mostly depended on private invitations. I think that could widen access if the criteria are published and appeals work. It could narrow access if the government simply formalizes the same small circle with another approval step.
There's also a strange incentive for the labs. A federal decision can absorb some blame. When a restricted model causes harm, the company can point to government approval. When a useful researcher is excluded, it can point to government caution. The state gets influence, and the company gets a second institution sharing responsibility. That arrangement may still improve decisions, but responsibility has to remain legible. The White House announcement names coordination. The next documents need to name the decision-maker, the record they create, and the route for challenging a denial.
A government role also changes how early access feels to the recipient. You're no longer receiving only a vendor preview. You may be entering a public security program with retention rules, reporting duties, and restrictions on who inside your organization can touch the system. Those conditions could make access safer and more useful. They could also make the best independent researchers decline. Gold Eagle is concrete enough to examine now, yet the access rules will determine whether it expands the circle of capable reviewers or gives the existing circle a federal seal. A separate proposal reported Friday would create an independent AI safety body modeled on FINRA, the securities industry's self-regulatory organization, with a reporting line to the Securities and Exchange Commission. This is distinct from Gold Eagle. One mechanism would influence access to particular frontier models. The other would review model safety through a standing institution. Putting them side by side is revealing because they answer different questions. Who may receive a model, and who decides whether the model meets a safety standard?
FINRA is an appealing analogy because it suggests technical supervision outside the ordinary rhythm of Congress, but analogies bring baggage. Financial firms have licenses, defined activities, examination powers, and long histories of record keeping. An AI model can be an API service, downloadable weights, a customized internal system, or a component inside another product. Before you copy the institution, you need a regulated object. Is the body reviewing the base model, the deployed service, a capability threshold, or the combination of model and tools?
The agenda around the proposal leaves those questions open, and the proposal hasn't become policy. Still, it is more specific than another call for AI regulation. A standing reviewer could build staff expertise, require repeatable evidence, and publish decisions that accumulate into precedent. It could also become dependent on the companies whose systems and personnel supply most of its technical knowledge. The SEC reporting line adds public authority, but it doesn't automatically answer who appoints the reviewers or how their standards can be challenged.
I keep coming back to the evidence standard. A lab can show benchmark results, red team reports, deployment limits, and logs from internal testing. A regulator then has to decide how much of that material becomes public without handing out an attack manual or a competitor's recipe. That tension is ordinary regulatory work, but AI compresses the cycle. A model update can change behavior faster than a formal rulemaking process can respond. The institution would need a way to review updates without pretending every minor revision is a new aircraft certification.
Today's cyber capability estimate makes that timing problem less abstract. An AI Security Institute analysis, summarized in the reporting collected by TechMeme, puts leading open-weight models roughly 4 to 7 months behind the closed frontier on cyber tasks. The comparison covers much of 2025. During that period, the estimate ranged from 6 months to 10. A benchmark gap doesn't tell you what attackers can accomplish in the world, but the shrinking interval gives policymakers a number they will use when arguing about whether access restrictions buy meaningful time.
And people can use the same number to argue opposite policies. One side sees 4 months of lead time for defenders and says access control is valuable. Another sees a short, shrinking delay and says restrictions concentrate defensive capability while the open ecosystem catches up anyway. The benchmark methodology carries more weight than either political reaction. Which tasks were tested, how much tool access the models had, and whether the score tracks a human operator completing an intrusion. The month estimate is informative, but it isn't a countdown clock to equal offensive capability.
That is why the 2 federal proposals need separate public records. An access decision can be temporary and applicant-specific. A safety determination can become a precedent that shapes many releases. Combining them would make it difficult to tell whether a company was denied because the model was judged dangerous, because the applicant was judged unprepared, or because the government preferred another use. Gold Eagle and the proposed reviewer may both develop further. Their credibility will depend on whether outsiders can reconstruct the reason for a decision without possessing classified details. Apple sued OpenAI, IO Products, and 2 former Apple employees last week, alleging trade secret theft tied to OpenAI's consumer hardware effort. TechCrunch and the Associated Press identified Tang Tan as one of the employees. He worked on the iPhone, Apple Watch, and iPod, and is now OpenAI's chief hardware officer. The other is Chang Liu, a former electrical engineer. Apple says OpenAI encouraged recruits to share confidential information and helped them avoid scrutiny during their departure. Those are Apple's allegations, and the court hasn't tested them.
The specificity changes the temperature. Apple isn't complaining only that talented hardware people moved across town. The complaint reportedly describes retained access, confidential files, recruiting conversations, and knowledge about unreleased products and suppliers. TechCrunch reports that Apple says Liu kept an Apple-issued laptop after joining OpenAI and used it to download confidential technical documents. An employee changing jobs is ordinary. Carrying protected material across the boundary is the conduct the lawsuit asks the court to examine.
OpenAI's hardware ambitions make the dispute unusually consequential. The company acquired Jony Ives IO in a deal TechCrunch valued at $6.5 billion, and the device effort is supposed to create a new way of interacting with AI beyond the phone and laptop. Hardware programs accumulate knowledge about materials and suppliers. Engineers also carry years of decisions about tolerances, radio behavior, battery limits, and manufacturing tests that rarely appear in a keynote. If a court restricts particular people or knowledge, replacing a team member doesn't necessarily replace the path that team already chose.
A trade secret case involving a device that the public hasn't seen creates an unusual disclosure problem. Apple has to identify the protected information precisely enough for a judge to evaluate it, while protecting the information from wider disclosure. OpenAI has to separate general expertise from Apple's confidential material. The case may expose pieces of both companies' future hardware thinking through sealed exhibits, expert testimony, and arguments over what an experienced engineer would already know. The legal fight can reveal the anatomy of an unreleased product without giving us the product itself.
There is also a partnership underneath the hostility. Apple integrated ChatGPT into its devices, and now it says the same company benefited from misconduct while building potential hardware competition. Companies can cooperate in one layer and litigate in another, especially when software partners start reaching for physical products. I don't think the existence of the suit proves OpenAI's device is delayed or compromised. It does mean every important design decision now has a second question attached. Which knowledge produced it, and can OpenAI prove that provenance in court?
And a settlement could be as influential as a verdict. It might restrict certain employees, require independent review of design materials, change supplier relationships, or simply exchange money for an end to the dispute. Each outcome affects the device program differently. Apple's strongest public advantage today is that its complaint supplies vivid alleged conduct. OpenAI's answer will have to turn that vivid account into disputed facts, ordinary employee knowledge, or information that didn't influence the work. Until then, the lawsuit tells us more about Apple's claims than it does about the device's actual design.
Meta and Anthropic are discussing a compute lease that could be worth as much as $10 billion over 2 years. According to CNBC's report on the talks, the discussions are early and may produce no deal. The basic transaction is straightforward. Meta has built enormous computing capacity, and Anthropic needs more capacity to train and serve Claude. The unusual detail is the counterparty. Meta develops competing models and products, yet it may also become a major infrastructure supplier to Anthropic.
I like the deal precisely because it makes rivalry less tidy. A company can compete at the model layer and sell excess or purpose-built capacity underneath it. Cloud companies have lived with that dual role for years, but Meta has usually presented its infrastructure as the engine for its own products and open model program. Renting part of it to Anthropic turns data center construction into a business line, assuming the economics and technical boundaries work. It also gives Meta another way to earn a return while its campuses come online.
A compute lease doesn't imply that Meta sees Anthropic's requests, waits, or customer data. The contract and system design would determine isolation and operations access. They would also govern incident response and the performance information that crosses the boundary. Anthropic already sources capacity from multiple large providers, so another supplier can reduce dependence on any single one. Every additional environment still asks the lab to reproduce training and serving behavior across different hardware, networks, and operational teams. Capacity is fungible in a spreadsheet long before it becomes fungible in a model run.
There is a power question inside the scheduling system. Who gets priority when Meta's own research run, an advertising workload, and Anthropic's reserved capacity all want the same constrained component? A serious lease answers that with physical separation, reserved clusters, or contractual priority. The answer will tell us whether Meta is selling a dependable product or monetizing temporary slack. $10 billion over 2 years sounds like commitment rather than a casual overflow arrangement, but the reported talks haven't produced terms we can inspect.
This also updates the old picture of frontier labs vertically integrating everything they can. They still want control over models, serving systems, and eventually custom silicon. In practice, demand keeps outrunning owned capacity, so they assemble portfolios of supply from companies whose incentives differ. The competitive boundary sits around access and confidentiality, while money crosses it freely. If the deal closes, the first useful evidence will be operational. When capacity arrives, which workloads use it, and whether Anthropic treats Meta as a durable provider in later agreements. Japan is reportedly planning to buy 27,500 Nvidia Rubin chips for a domestic foundation model aimed at robotics. The TechMeme summary of Bloomberg's report names Noetra, SoftBank, Sony, and NEC as participants. This is still a plan. A chip order isn't a trained model, and a trained model isn't a useful robot. The compelling detail is that the national project begins with a defined application domain, instead of promising a general chatbot that will somehow serve every ministry and company.
Robotics gives the project a demanding customer on day one. The physical world. A useful system has to connect language and vision to motion. It has to manage timing and force, then recover when an object isn't where the model expected. Japan also has deep manufacturing and robotics expertise. The participating companies already understand sensors and motors, along with the industrial environments where machines work. The model team can ask those partners for tasks and data that correspond to machines people already build. That is a stronger starting point than inventing benchmarks in isolation.
The chip count makes the ambition measurable without telling us performance. Rubin capacity can support large training and inference workloads, but the data and architecture will determine model quality. Simulation and access to physical platforms will determine whether it works on machines. The participating companies also have different incentives. SoftBank may care about infrastructure and investment. Sony brings sensing and embodied interaction. NEC works in industrial systems, and Noetra appears to be coordinating the foundation model effort. Those roles need confirmation as the plan develops, but the named group already suggests an industrial consortium rather than a lab operating alone.
A sovereign model can also be valuable without winning a global leaderboard. Domestic companies may care about Japanese language and factory procedures. They may also need support for locally common machines, domestic data storage, and tuning inside proprietary environments. The hard part will be getting companies to contribute the operational data that makes the model useful while protecting the processes that give each company an advantage. A national purchase can buy chips. It can't order trust among participants, and robotics datasets often contain far more commercial detail than a public web crawl.
This project is early enough that restraint helps. Today's source has no model card, training result, or deployment report. It gives us a planned procurement with named participants and a robotics objective. That is already more concrete than many sovereign AI announcements. The consortium can fill in the missing pieces by identifying the cluster operator and the robotic tasks that define success. It also needs a method for manufacturers to contribute data without surrendering it to every other member. Two AI engineer talks published this morning focus on agent deployment and checkpointing, and a new paper proposes a proof-or-stop control layer for lifecycle decisions. Taken together, they describe a practical sequence: an agent's instructions, tools, or memory policy changes. A small cohort receives the new behavior. The system preserves enough state to replay what happened. Then a separate check asks whether the agent produced evidence that justifies continuing. These are proposals and engineering patterns from 3 artifacts, rather than one standard product.
The behavior level cohort is the detail I care about. A conventional feature flag often says that 10% of users receive a code path. An agent change may alter which tool it chooses, how long it persists, what it remembers, or when it asks for approval. The cohort has to capture the behavior and context, not only the software version. Otherwise, you know which users received the new instructions, but you can't explain why one agent deleted a draft while another asked permission.
Suppose the change lets a support agent issue a refund after reading an account history. The canary limits the new policy to a small set of eligible cases. A checkpoint records the conversation and the account facts the agent retrieved. It also preserves tool calls, approvals, and the current lifecycle state before money moves. If the agent behaves strangely, An operator can replay the same case from the checkpoint with the old policy and compare the decisions. The investigation begins with a recoverable execution state instead of a loose collection of logs.
And replay has to respect the world outside the agent. You can replay the reasoning path, but you shouldn't issue the refund twice or send another email to the customer. The runtime needs to distinguish observations from side effects and substitute recorded results when a replay reaches an irreversible tool call. That separation is difficult, yet it is also where agent engineering becomes more interesting than ordinary request tracing. The execution record is partly a program trace and partly a history of commitments made to people and external systems.
Proof or stop adds a decision gate after that execution. The paper's abstract describes verifiable evidence-gated lifecycle control. The authors say they evaluated an open-source implementation with mechanism tests, a control policy ablation, and evidence from operating the system on itself. In our refund example, the payment tool must return a receipt before the lifecycle can advance. The record must also show that the policy matched and any required approval occurred. Missing evidence stops the transition.
That makes completion a claim another component can inspect. The agent may still write a persuasive explanation, but persuasion doesn't move the state forward. A verifier checks the receipt and policy conditions. I like this because it gives autonomy a visible boundary without demanding that the model become perfectly reliable. It also creates new design choices. Evidence can be stale, forged by a compromised tool, or technically valid, while the underlying policy is wrong. The verifier needs fewer freedoms than the agent, and its inputs need provenance.
The three pieces reinforce one another without becoming one product. A canary limits who encounters changed behavior. Checkpoints preserve the state needed to understand and replay it. Evidence gates decide whether a lifecycle transition may proceed. Conventional deployment systems can provide parts of this, but they don't automatically understand an agent's memory, tool commitments, or claim of completion. The deployment unit now includes the code version and instruction set. It also includes the model and its tools. The memory policy, retrieved context, and evidence required for each consequential action belong to that unit as well.
Sieks, chuckle, which is a rather elaborate way of discovering that an autonomous system needs receipts. Still, the receipt is a powerful idea because it turns a vague demand for trustworthy agents into something you can inspect. Did the system consult the required source? Did the tool return success? Did a human approve the exceptional case? You can argue about those requirements in advance, then test the record afterward. The model remains probabilistic, while the permission to continue can be much more constrained.
This weekend's policy stories are also asking for receipts, just at institutional scale. Who granted access, which standard they applied, and what record survives the decision. The analogy ends there. The agent control artifacts give us concrete mechanisms today, while Gold Eagle and the proposed regulator still need public rules. Washington's next documents can resolve the central uncertainties by identifying the decision-maker and the evidence an applicant may submit. They also need to name the appeal body that can reverse a denial. Lenar Kess.